Okay, ladies and gentlemen, day 4 of Cisco Live 2023. Let's get this show on the road here at the World of Solutions. Just to let you know, we've got another packed full schedule here at the Partner Theatre, so check out the schedule on the Cisco Live app as well. Not only presentations, we've got live demos happening as well across today. But I'll hand over for our first presentation of the day now to Chief Architect from App Dynamics at Cisco Systems, Jeffrey Hendry. Thank you, ladies and gentlemen.
Thank you. Awesome. All right, good morning. I didn't attend the keynotes today. I hope they were interesting. I did attend the keynote on Tuesday, and for me, one of the most exciting things that was mentioned was the tech preview of Cisco Full Stack Observability Platform, which is going to be generally available in June. So I was trying to think of just some more interesting and engaging way to describe what full stack observability is. So I was thinking about where does all the data in the world come from, right? If we take out binary data, right? If we take out photos and videos and stuff like that, is most of the data generated by people writing articles, right? Text. Not really. I can fit all that humans have ever created onto a USB stick in my pocket, right? It comes from the machines, right? The digital exhaust from the logs, the events, the traces that these programs, servers emit. And why do they emit them, right? The developers who wrote that code are hoping to use that information that they emit to better understand the systems. So for many, many years, those of us who have done server-side coding, we use different logging libraries, right, to emit logs. And we use different systems to, in the olden days, just shell into a server, look at the logs, try to figure out what was going on, right? That's a very labor-intensive, point-specific approach that you typically only use when there's some kind of fire, right? Some problem. Okay, I got to get onto this server and start grepping logs and finding out what's going on, right? So the next evolution of that was the gathering of all of these logs into single, basically storage systems, append-only log stores that gave you user interfaces and query languages to search over those logs. More recently, there have been advances in something called open telemetry, right? Which is about being able to provide real telemetry signals, not just logs, right? Because a lot of times what we were doing in our logs was we were writing out logging statements that said something like, process credit card took 220 milliseconds, right? And then we were using the logging tools to go through all of those logs, extract the bit of text that's had the number of milliseconds, turn it into a metric, right? Now OpenTelemetry is giving you the way to emit a log when you need a log, emit metrics when what you actually want is metrics, right? And emit these things called traces, which allow you to debug and follow the flow through your program, right? So Cisco Full Stack Observability Platform is a platform for managing these metric events, logs, and traces that enable full stack observability. And full stack observability means being able to correlate problems up and down your stack, the user interface, the actual business problem, all the way down to the particular pod where the problem occurred, without having to do those point-specific, like, let me go to that server and investigate the problem. So making that all much easier and more proactive. The extensibility part means enabling our partners and users to add functionality into that system to address their own use cases. And that is actually a very novel and very hard problem to solve. And I think we have a really neat approach to it. And I hope to get that message across in this short talk about how it works. Okay, I'm gonna try not to go into these type of bullets that you've heard over and over, because I think I already gave you the basic story of why full stack observability is super, super valuable. The company, the part of Cisco that I work for called App Dynamics is really well known for its solutions for something called application performance monitoring. And application performance monitoring has typically focused on these little squiggly lines, right, which are basically metrics, right? And so you're looking at performance, and what APM does, what App Dynamics does, is enable you to build what we call an entity-centric model of what you're observing, right? So in the olden days of, like, I have a giant pile of logs, there wasn't a map of your infrastructure that would tell you which logs come from which servers. You kind of had to put all that together yourself. App Dynamics is known for providing you this automatic mapping of your topology of your infrastructure, which is, maps are arguably the most important visualization humans ever created, real maps, but also logical maps of your infrastructure. That's one of the key and most important things to full stack observability, is having the context and the relationships, right? A map can tell me that this pod is related to this service, right? When you're just looking at a pile of logs, you have to put that context together yourself. So App Dynamics is up-leveling this to make it much, much easier. Okay, so there's this acronym MELT, Metrics, Events, Logs, and Traces. And I think of this as the raw material for full stack observability. Traditionally, there has not been one system that can bring together metrics, logs and events, and traces, right? It's because these things have different characteristics that are needed for their storage and query. You'll find point-specific languages in the industry for querying MELT, right? And MQL, different metric query languages. You'll find different query language for logs and events, proprietary ones like SPL, things of this nature, right? We're, with the FSO platform, providing a single place where all of this information is stored, all of the different MELT types, and a single query language for querying and correlating across all the MELT types. That is a very new technology, and it's unique to the FSO platform. This is a picture of something called App Dynamics Cloud, which is a product that App Dynamics released last June. At that time, we didn't mention anything about FSO platform, okay? What is very, very interesting is that App Dynamics Cloud is built on FSO platform as an application. And I'm going to be talking a lot about that in this presentation. And that to me, that is really mind-blowing, because Cisco FSO Cloud is a very complex product, right? With beautiful user interfaces. It introduces a whole new way to manage and understand the topology of what you're observing. We call this the relationship map. So the relationship map will tell you, for whatever piece of your infrastructure you're focusing on, what is related to it. And it includes a modeling language called FMM, Flexible MELT Modeling Language, that allows you, the user or developer or partner, to augment the domain models that we already have. We're coming out of the box with domain models for Kubernetes, infrastructure, AWS, Azure, right? These show you the topologies of those systems that you're monitoring, okay? If you had a new topology, maybe it's something that doesn't really even directly relate to computers, like the transit system here is GVB, right? Okay, what if GVB wants to model their infrastructure and have an entity called vehicle with subtype, train, bus, etc., and another entity called station? And what if the business metrics that they really want to measure are on-time performance of different vehicles and queue length at different stations, right? That's business thinking. You can build that type of model, right, and correlate all the way up and down the stack, so that when you see a queue length increasing on a particular turnstile, you may be able to correlate all the way down into the infrastructure logs for the hardware that's serving that particular turnstile to figure out what's going on, what's going wrong. Topology is this concept of the map that I talked about, and our flexible modeling language for modeling these entities as open, and you can do it. So we believe in this metrics, events, logs, and traces, and topology. And we call it entity centricity. So in addition to the metrics, events, logs, and traces, our store has an additional store called the topology store. And you'll see it expressed in the query language, because in the query language, you can query for entities of a given type and get the logs for them and get the entities for them. Excuse me. So this is a short video about App Dynamics Cloud.
Observing multiple cloud-native workloads in real time, that's tough. Modern systems have grown so complex, they're now beyond human scale. And that's a problem, because any weak link in your infrastructure can bring your system to its knees, tanking your app and ruining your business. But it doesn't have to be that way. Welcome to App Dynamics Cloud, our groundbreaking cloud-native observability solution. Get all technical health data in one place. Visualize relationships dynamically. Analyze across silos. Understand root causes instantly. That's App Dynamics Cloud, engineered for open telemetry, providing industry-leading Kubernetes troubleshooting, designed to make collecting, accessing, and correlating data across various providers and containers delightfully seamless, so that you can create the sort of experiences your customers deserve and demand. That's how you shape the future of apps. That's how you observe what matters. That's App Dynamics Cloud.
Cool. Observe what matters. Good slogan. I like it. Okay. So last June, I mentioned that we launched App Dynamics Cloud. And at that time, App Dynamics Cloud was actually still kind of a silo within the Cisco business. But we launched a journey, if you will, to bring App Dynamics Cloud, to separate it out from this infrastructure we had built, and to kind of christen this infrastructure underneath it as the Cisco FSO platform. And the idea there is to provide this common melt substrate for us to use, but also for anybody to use. To draw a very clear line, an API and SDK, between the Melt platform and the applications, so that the applications we ourselves are building are using the same API and SDK that you're using, right? So if you think about it, if we are able to build an application as complex and feature-rich as App Dynamics Cloud, imagine what you can do on the platform, and imagine how you can enrich App Dynamics Cloud. So we're allowing for two kinds of applications on the platform, or solutions as we call them. One of them is just a freestanding Cisco FSO platform solution, like doesn't have to have anything to do with App Dynamics Cloud. The second is what we call an enrichment to App Dynamics Cloud, which allows you to make specific enrichments, enhancements to those screens that you kind of got a preview of before. And I'm going to walk through some enrichments that we actually already built to demonstrate how to use it. Again, this is the marketing picture of our architecture. I'd like to get into a little bit more detail. What we're going to have at GA are this enrichment from Apsani, this enrichment from Replex, and there are going to be some other partner enrichments that are announced as well. So there are also eventually going to be other fully freestanding applications. At first, the only freestanding big application will be App Dynamics Cloud, but there'll be multiple enrichments available on a subscription basis. Inside of the FSO platform and App Dynamics Cloud, there is the ability, like you would get with most IDEs, right, to list the available enrichments and to subscribe to them. And if you don't like them, you can unsubscribe from them, right? So you'll be able to, like any other app platform, get details about it, browse what it does, and give it a spin. Okay, why extensibility? I mean, in a nutshell, we can't write all the code, right? The number of features that our customers have asked us for, and I think this is true at many, many companies, right, eventually begins to overwhelm the engineering teams, right? So on our existing product, AppDynamics, it doesn't have this clear separation between, okay, here's the platform and here's the application. So when we need to add new domains of business, we call them domains, like Secure App, like integration with Thousand Eyes. These are like coordinated engineering projects, right? Where people at that company are talking to a project manager at our company. There has to be like a good strategically aligned interest in doing it. Engineering teams have to get spun up on that work. Meanwhile, those engineering teams can't work on the platform, right? So from my perspective, one of the reasons to have an ecosystem is to sort of get your own, it's selfish, right? Get my own engineering teams freed up to work more on core features by empowering partners, right? But also even empowering internal teams to be able to build more like external partners, right? If I give an internal team a very clear API, right? And just say, yeah, read the docs, right? It's the same as an external partner would use. It's actually much easier to hire people for that team, right? It makes everybody's life easier. So extensibility provides for a very clean development model for what? Well, I didn't mean to advance that slide. Okay, it provides a clean development model for first-party apps, like the things that used to be just kind of like a tab within the AppDynamics product, but this is really just all coded into the core. Those aren't coded into the core anymore. They're built basically as apps and enrichments on the platform using the exact same APIs that second parties and third parties would use. So, obligatory iceberg slide. We want to build a few of these things, but make the vast bulk of what's available to you on an app exchange. And, I can't wait for someone to build something that's more interesting than, what we've thought of at AppDynamics, right? That will be very exciting. So the roadmap for the Cisco FSO platform is that it's currently in a tech preview. We did deliver a 4-hour training yesterday, which I understand got very, very good feedback. If anybody has used Kubernetes, you may be familiar with a tool called kubectl. We built a tool for our platform that we call FSOC. A lot of the training was teaching people how do you build a solution package, how do you push it with FSOC, how do you kind of administer your solution using this tool. And we built a reference solution for our platform called Spacefleet. And it adds a Star Trek-like experience into the user interface with an event generator that simulates things like torpedoes, shield levels, like all these different interesting metrics, events, logs, and traces that have nothing to do with like a traditional monitoring domain. And the purpose was to show people how extensible this platform can be and what you can do. That was very exciting. Okay. We started thinking ourselves about, for the general availability, what features in our own product can we build as enrichments? Because as I was saying earlier, it's actually easier for internal teams to build on a clear API, and we wanted to eat our own dog food. So, AppDynamics had acquired a really cool company called Replex that has a technology for understanding the cost of everything running inside your Kubernetes cluster. And I know from experience that this is a really big deal. Developers generally have no idea what the cost of the stuff they're rolling out is, and we tend to over-provision out of paranoia, right? So it leads to a lot of idle, and this is real screenshot of it running off of some of our own systems, right? So you find a lot of idle services. So if you can understand what your idle costs are over time, and if you also had a way to optimize what you were running in your cluster that would actually sort of automatically tune down the amount of memory used for things, or optimize them in other ways, like optimizing the amount of CPU they were allocated, you could really be in good shape. So the Replex solution will make you recommendations for what to do, but we actually have an additional enrichment called Optimize, built by some really brilliant people coming out of a company called Opsani that we acquired. And this has an agent that you actually deploy into our Kubernetes cluster, and it talks to apt Cloud, where they've built an enrichment that actually uses machine learning to tune the parameters for real live in your Kubernetes cluster. Like, let us adjust down the amount of memory by 5% on one pod in a canary-like fashion, and it will actually optimize your cluster. And when you put these two things together, Replex and Opsani, it's going to be, we think it's not just like a cool example of how to use the platform. We think people will buy this functionality, that this is super valuable functionality. So those screenshots that you saw before, I didn't show you them in the context of actually being in AppDynamics Cloud. So as a developer, how would you actually get your desired user interface into AppDynamics Cloud, right? That was actually another kind of like pretty challenging technology, because we didn't want to just say like, yeah, write JavaScript, right? That is not secure. Sure, just write JavaScript, like grab the bearer tokens and exfiltrate them somewhere, right? So no, we had to develop a technology that was safe for third parties to put inside of their solutions that would enrich our user interface in a secure way. So security really being and ease of use being the most important considerations there. So our UI is built on something that, well, the truth is we don't have a good name for it yet. We just call it templated UI, but we'll hopefully have a name picked before we go GA. But when you author a templated application, and apt Cloud is literally the observe experience in apt Cloud is a templated UI. When you make a templated UI page, you, the author of that page, get to decide what third parties can extend on your page. So you get to decide if, additional panels can be added here. So we built our observe. This is called an entity-centric page. It's a page that's providing you details about a particular entity that happens to be a pod. You've navigated your way to this pod through our user interface, hypergraph, relationship map, all those cool things. So this is the Replex solution that this particular tenant has subscribed to. And the Replex solution, without any coordination with the authors of apt Cloud, right? You just look at the apt Cloud solution, which is itself open source. You look at its templated UI page, which is a JSON file. You can see from that what it allows you to extend, and then you can create extensions that define your own templated UIs that will load into the page for anybody who has subscribed to your solution. So this is pretty novel, pretty cool stuff. Here's an example of another page in the solution. This is called the entity list view. And they've augmented the entity list view so that they can show the total cost and a score for every entity that you're observing. Now, a really interesting thing to think about is, where is the data for those total costs and other metrics that they keep stored? How did they tell the system that for every Kubernetes entity, you need to be keeping a few additional metrics, including the cost? Okay? Did they have to get our Kubernetes domain model and edit every single entity in it and then ask us to uptake that change with a PR? They did not. Right? So we're designing everything from the UI to the FMM to support this concept of distributed development, where you can do things in a safe way without lots of communication with another team. So the FMM modeling language includes a construct where you can make an extension in another domain that you can be very specific. You can say, I want to add these metrics to a particular entity in another domain, like a pod, right? That change will only be seen by people who subscribe to your solution, right? It won't affect anybody except the people who want that. But you can also say in one shot, basically a one-liner, I want to add a metric called total cost to every entity in another domain like Kubernetes. So you really don't even have to understand, if you don't want to, in great detail, a complex domain model, right? If you were providing some functionality to add cost information to AWS or Kubernetes, you could say, I want to add the cost metric to every domain in our every entity in our AWS domain and every entity in the Kubernetes domain. That would be basically 2 lines of code. So that's a bit about how the back end and the front end are both extensible. You put those artifacts into a solution, and you've got something that enriches the UI and many different screens of the UI in really cool ways. Okay, here is a deeper look at the architecture of our platform. Data gets into the platform in 2 ways. Open telemetry, which is really hip, it's the future, everyone's going to do open telemetry. However, the reality is that there are tons of other forms of data you want to get in, right? The world is full of APIs, right? So as I was saying, in the world of the non-App Dynamics Cloud product, when we want to integrate with something with Thousand Eyes or something like that, that's, again, like an engineering-to-engineering conversation. There's nothing self-service about it. If you wanted to get the App Dynamics product to pull in data from something you have as a partner, develop a business relationship with someone, take them out to lunch, right? However, and good luck, now you are completely empowered to not have to talk to anybody and to build a solution that places your own containers for what we call cloud collection inside of the solution, so that when somebody subscribes to your solution, these containers that you write the code for in the language of your choice can go out and grab data from other APIs and bring it in. Now, there are some really cool nuances to that, right? Someone's going to subscribe to your solution to pull data from, I don't know, a Git repo that you wrote a monitoring solution for, okay? How do you get their API keys, right, to access this other API on the web? That is a really cool technology that we've built into this cloud collection framework. Your code will never see those keys. It's really cool. The tenant will enter those into the settings for your solution, and we actually use egress proxies to inject these keys into outgoing requests. So you have a zero trust relationship with the person who's subscribing to your platform. They do not need to trust your code. Your code will never be able to see their API keys, and it will never be able to exfiltrate it. It's actually really awesome technology. Once the data lands in the platform, you may need to do some custom processing on it. Your solution can, and so by the way, everything that's a gear is something that you can write essentially a declarative program for and place into your solution. So you can tell from the time, I can't go through all of the gears in detail, but your solution can have any mixture of these things. You could make a solution that was just a new entity model. Like, hey, I'm just making a library that is just a cool entity model, right, for other people to use and leverage. Or, hey, I'm making something that's a collector for data from Salesforce. Or, hey, I'm making something that collects data and visualizes it into the platform. And we have this unified query language called UQL. It queries across all of the metric, event log, and trace stores. There's something in the platform called the knowledge store. This is also amazing. Knowledge store enables you to bring things that aren't melt to the platform, right? What if you want to make a solution focused on security? And investigation is a concept that you are bringing to the table, right? It's not melt. You need a place to store the definition of your investigations. And you need to be able to define new roles that are new to the platform. Security investigator, security admin, right? Complete approach to building new APIs and collectors for our platform. As I was saying, the solutions that you build can be any combination of these things. There's actually like 7 different things that you can configure in the platform, so there are lots of different possibilities. We call the thing a solution package. Into your solution package, it's just a tar zip file. We give you the tools for building those and pushing them to the platform. This is another view of the platform, kind of instead of a layer cake view, it's kind of a data flow view, open telemetry, stuff you gather, custom APIs that you add, knowledge store, data processing, unified query language, flexible application UIs. And we built a very sophisticated one of these solutions called App Dynamics Cloud. There are some other sessions. The order was a little weird. I'm giving the overview of full stack observability on Thursday, even though we had the training deep dives on Tuesday and the getting data in deep dives on Tuesday. So unless you have a time machine, you can't catch many of these, but maybe you'll be able to catch the videos. We're going to have additional deep dive trainings, and I think my time is up.
Pretty much, Jeffrey, but thank you. A great insight there. Ladies and gentlemen, big round of applause for Jeffrey Hendry there, Chief Architect of App Dynamics at Cisco Systems. As he mentioned, all presentations will be made available after the conference as well, so make sure you stay in touch with Cisco if you want to see any of the previous ones that Jeffrey mentioned there.